Then we take more examples. We are said from this question, form the ordinary differential equation corresponding to these equations. We have to find the ordinary differential equations that is corresponding to these equations. So example now says y is equals to ax plus x squared. Y is equals to ax plus x squared. Example number 1, y is equals to ax plus x squared. Looking at this equation, you will observe that it has one constant, which is a. So we have to differentiate once. Differentiating this, going to have dy over dx is equals to, if you differentiate ax, you're going to have a, because the power of x is 1, it is spiritual. We'll come and multiply everything raised to power. That 1 minus 1 is going to give us 0. And anything raised to power 0 is 1. Therefore, we have differentiating ax, we're going to have a. If you differentiate x squared, you're going to have 2x, because 2 will come and multiply the power, which is 2, will come and multiply raised to power that 2 minus 1. Therefore, we have 2x. And if you look at this equation, since we have to differentiate once, it only has one constant, so we differentiate once. That's why you differentiated once. So after differentiating once, what we do now is to make a the subject of the formula. After making a the subject of the formula, we substitute for that whatever we got for a in equation 1, in this first equation. We substitute for that whatever you got from here for a in equation 1. Equate everything to 0. That will give us the ordinary differential equation that is corresponding to this equation. So to do it, to make a the subject, you just simply have to move 2x to the other side, cross it over. Here is positive. If you cross it over, it's going to be negative. So we have dy over dx minus 2x. dy over dx minus 2x is equals to a. Now you substitute for this. Now you substitute this for a whenever you. Now you substitute this for a in equation 1. Therefore, in equation 1, we have y is equals to ax plus x squared plus x squared. Therefore, we have y is equals to, if you put this, dy over dx minus 2x, since a is equals to this, so we substitute for a for this in equation 1. That's why I have dy over dx minus 2x, all multiplied by x, plus x squared plus x squared. Solving this, y is equals to x multiplied by dx, dy over dx, we have x dy over dx. X multiply with minus 2x, going to have minus 2x squared plus x squared. Y is equals to x dy over dx minus 2x squared plus x squared. That is simple as saying minus 2 plus 1. You're going to have minus 1. Therefore, minus x squared. Rearranging and equating everything to one side to get our ordinary differential equation, we're going to have x dy over dx minus x squared. Y is positive here. Once it crosses over, it's going to be negative. Minus y is equals to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation. Now, let's move over to example number 2. Going to example 2, y is equals to a sine 3x plus b. Question 1. To differentiate this, we have to differentiate twice, because we have two constants, which is this a and this b. So we say dy over dx is equals to, this is a product rule. A is multiplying sine 3x plus b. And to differentiate this using the product rule, the differential of a is going to give us 0, which is because a is a constant, multiplied by sine 3x plus b, still give us 0, plus differential of sine 3x plus b multiplied with a. And to get sine 3x plus b, differential of sine 3x plus b, some might just use the traditional method. Traditional method is You say to find the sine 3x plus b, differential of sine 3x plus b, you know y is equals to sine 3x plus b. You say let u be 3x plus b. Therefore, du over dx, if you differentiate 3x plus b, you're going to have 3. But y will now be sine u. Since u is equal to this, y is going to be sine u. Differentiating y with respect to u, differentiating sine going to give you cos u. Therefore, dy over dx is equals to du over dx multiplied by dy over du. This is the traditional way. Du over dx is equals to 3. 3 multiplied by dy over du is equals to cos u, which is equals to 3 cos u. But u is equals to 3x plus b. Therefore, 3 cos 3x plus b. 3 cos 3x plus b. This is the differential result if you differentiate sine 3x plus b. But this is the traditional way, and it often takes time to solve it using the traditional way. So what I do is this. Since you have to differentiate sine 3x plus b, the shortcut is this. Sine 3x plus b. What you do is just differentiate the content. What is the content? The content is what is inside here. So the content here is 3x plus b. I'll differentiate the content. If you differentiate the content is 3x plus b. If you differentiate it, you're going to have 3. Because b is a constant, it's going to be 0. Differentiating 3 is going to have 3. 3, then once you differentiate the content, you write it, then differential of sine, you're going to give you cos. Then you write everything back. 3x plus b. Just know it like this. Differentiate the content. After differentiating the content, whatever you get, multiply it by differentiating what is outside plus the initial content. That is why you have 3 cos 3x plus b. It's still the same thing as 3 cos 3x plus b. So differential of a is going to give us, a is a constant. Differentiating a is going to give us 0. Multiply with sine 3x plus b is going to give us 0. Plus differential, if you differentiate sine 3x plus b, we're going to have 3 cos 3x plus b. Multiplied with a, we're going to have 3a cos 3x plus b. We have to differentiate again because we have two constants. Differentiating again, the squared y over ds squared. The squared y over ds squared. If you differentiate this again, remember 3a is dependent, as independent, and cos 3x plus b is independent. That is, two of them are multiplying each other, and we use the product rule as we did in the previous example. So how we do it? Differential of 3a. If you differentiate 3a, 3a is still a constant. If you differentiate it, you're still going to have 0. 0 times 3 times cos 3x plus b, going to give you 0. If you differentiate cos 3x plus b using my short form, what is the differential of the content? If you differentiate the content, what is inside that is cos 3x plus b is the content. If you differentiate it, you're going to have 3. 3 multiplied by differential of cos. If you differentiate cos, what are you going to get? If you differentiate cos, let's write it here, cos 3x plus b. If you differentiate the content, which is 3x plus b, you're going to have 3. If you differentiate cos, you're going to have minus sine, writing the initial content sine 3x plus b. This is going to give us minus 3 sine 3x plus b, right? So after differentiating this is what you're going to have multiplied by 3a. If you multiply 3a with this, going to have minus 9a sine 3x plus b. That is if you multiply this with this. So minus 9a sine 3x plus b. Minus 9a sine 3x plus b. So what we are going to do now is this. Since this is our, so we have the squared y over ds squared is equals to minus 9 a sine 3x plus b minus 9a sine 3x plus b. If you look closely, we can factor out minus 9 so that it will be equals to the first equation, which is y is equals to a sine 3x plus b, so that we substitute this for y and equate everything on one side. That will automatically give us the ordinary differential equation that is corresponding to this equation. So doing what we just said now, we said d squared y over ds squared is equals to, if you move out 9, minus 9 bracket a sine 3x plus b. You know, this is still the same thing as this, because this minus 9 is going to multiply what is inside, which we are going to have minus 9a sine 3x plus b. But if you look closely, y is equals to a sine 3x plus b. So we substitute this for y, going to have d squared y over ds squared is equals to minus 9y. Now, moving y to the other side, y is negative here. Once it crosses over, it's going to be positive. Now we have d squared y over ds squared plus 9y is equals to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation.